Where do you see the greatest benefits for companies adopting contemporary automation strategies, and what values do these new technologies generate?
Well, over the last decade, our automation has changed a lot. The control equipment got more and more powerful. It integrates more easily with IT technology. And in the end, networking equipment is today not an option anymore. It is really a must. You must do that to be competitive. And all these changes basically brought us a better understanding of our process. We can now more easily optimize our production with a higher computing power of today's PLCs, with a higher precision of sensors, with a faster networking. All that allows us to save on resources in the end. Let me explain it quickly. For instance, if you have an injection molding machine, you can today produce thinner parts because just of the higher accuracy of the machinery, and therefore use less resources and have less cost. So automation today allows us to make optimizations that couldn't have done before.
What role is automation playing in manufacturing today?
The big challenge in our industry today is time to market. It isn't not enough anymore to really strive for a high level of automation, for instance, to reduce the cost of production, of mass production. Today you need to be able to adapt quickly, follow trends in the market quickly, and of course have shorter product life cycles. We all are used to this from, for instance, mobile phone market or computer market, where the product life cycle is very short. But this happens now in more traditional industries as well. For instance, there's a project of the European Union called F3 Factory Program, which basically has the goal of the chemical industry to combine the efficiency of world-scale plants with the flexibility of batch processes, to be way quicker and to respond to market trends way quicker. Another example, for instance, is the automotive industry, where with adapted safety features very early. For instance, in Profibus and Profinet International, we have our Profisafe standard there, and that allows for a working environment where a worker and a robot work closely together, where you had in the past a lot of safety fences, and you don't see them in manufacturing plants anymore. And this open environment provides much more productivity and, of course, allow for an easier change.
How is automation technology responding to the challenge of energy management?
First of all, there are two main aspects why companies think about energy management, energy consumption, and drive for a more green production. The first one, obviously, is the financial aspect. If you pay for energy and prices are raising, every cent or penny you save on energy costs, of course, will directly add to your bottom line. The second one is about the image of a company. For instance, the car manufacturers, again, are here in the driving seat. They want to be seen as green and energy efficient. And so Mr. Winterkorn, as an example, the CEO of Volkswagen, sets a target for the Volkswagen production to save 25% in energy and water consumption until 2018. So this is why the car manufacturers, the German Car Manufacturer Association, approached Profibus and Profinet International 5 years ago to jointly develop the Profi Energy Profile, which is a communication profile that allows a controlled shutdown and startup of parts of the production which are currently not used. With this, they can save up to 80% of their energy costs during their breaks.
What are the new trends in plant maintenance?
Well, higher productivity obviously is a key for staying competitive in the global market, and engineers need to make sure that the plant keeps running. With field bus communication, with the introduction of field bus communication in the late 90s, well, we gave engineers a tool at hand that they easily can detect errors in devices, could see if something was broken, and of course fix it. They immediately know where the fault happened, and so they could quickly replace it, which of course minimizes standstill of the plant. more like a condition monitoring approach, which allows not only monitor automation devices, but entire machineries, production lines, and things like that, and get a clear state of the current unit easily. The drawback of that is that today there's not a standardized system for that. So if you want to do that, if you want to implement that, you need to use proprietary systems, and you have higher efforts in implementing that. So this is why, for instance, the German Machine Building Association has formed a new working group for a field-based neutral reference architecture for condition monitoring systems in factory automation, and of course, Profibus and Profinet International is working closely with them to drive that standard.
What is the current thinking around Industry 4 and smart factories?
Well, first of all, the term Industry 4, it's branded by the German government, but might be a little bit misleading because it's not a real revolution. It's more like a process, an evolution, and in my opinion, we are already in that process. The idea behind all that, for instance, the idea behind smart factories in a very short sentence is that the product itself knows what is needed to produce it, and it communicates with intelligent machines to execute the production. So whenever there's a new production order, the production machine autonomously organizes themselves to fulfill that order. And of course, the potential for that is enormous. It allows a cost-effective production, basically of batch sizes of one, so mass production, a customized mass production. For that to be worked, you really need cyber-physical systems or the Internet of Things, which brings a totally new level of communication to the entire product lifecycle.
How will the Internet of Things lead to greater productivity and efficiencies?
To make Industry 4 happen, you need the Internet of Things or cyber-physical systems, which is another term for that. In short, cyber-physical systems evolve from embedded systems, but embedded systems are mostly standalone systems, but cyber-physical systems, on the other hand, add extensive communication to that. They form a connected production environment which is capable of instantaneously adapt to changes or disruption of the process. For instance, if one machine fails and there's already a production order running on it, another machine can take over automatically. That is all self-organizing. Furthermore, in the digital factory concept, which is related to that cyber-physical systems are connected to the entire product lifecycle as well. So that means when you design a product as a designer, you can work with the production as well, the production line as well, with the machinery as well. You have a virtual machinery which gives you immediately feedback of what changes you do. If the designer changes a product and makes adjustments to it or modifies it, he gets feedback from that cyber-physical system, what that means in terms of product time, resource consumption, and all that kind of things. So you get directly feedback. This really leads to a whole new way of working in our industry, in our business. Of course, all the different partners need to work more closely together. They are more connected to each other, such